In our previous lesson on atoms, we actually opened up the atom and met its inhabitants. And what were those inhabitants? We met the proton, the electrons, and the neutrons, and we discussed them extensively. And then we used PEN, P-E-N, as a way of remembering them. That was quite interesting. If you haven't watched that lesson, then it would be advisable to watch that before watching this, because this is a continuation of the previous lesson. Now, scientists have discovered these 3 subatomic particles that we discussed earlier, but soon they faced a new challenge, a completely new problem. And here's the challenge they faced. All atoms have these same 3 subatomic particles, whether the atom is a sodium atom, an oxygen atom, a nitrogen atom, no matter the element from which that atom it comes from, no matter the kind of atom it is. These atoms have the 3 subatomic particles, the same proton, neutrons, and electrons. If that is the case, so why is oxygen or hydrogen different from carbon? Why is hydrogen completely different from carbon? Because hydrogen atoms have protons, neutrons, electrons. Carbon atoms have protons, neutrons, electrons. These are the 3 things they all have. Aside this, that's all. So why is hydrogen different from carbon? And why is oxygen not the same as nitrogen? Why? Why the difference? But they all have the same 3 subatomic particles. So these are valid questions for scientists to ask. And these answers were actually hidden in numbers. Yes, literally, they were hidden in numbers. So this is learner's aid, where scholars are made. As scientists compared different atoms, they noticed something remarkable. They'll pick atoms of oxygen and compare it to atoms of nitrogen, and pick atoms of maybe potassium or carbon and compare them. They noticed something so remarkable. And here is it, that every atom of the same element always had the same number of protons. Every atom of the same element had the same number of protons. What does that mean? This is what it means. If you pick hydrogen, the atoms will always have only 1 proton, not less than 1, not more than 1. So hydrogen atoms always had 1 proton. And then oxygen atoms always had 8 protons. So if you pick oxygen, it's made up of a lot of atoms of oxygen coming together to form oxygen. These atoms, each of them have only 8 protons. And when you pick sodium, they always had 11 protons. No less than 11, not more than 11. This was what they noticed. So that discovery led to an important idea. And the idea was this, that the number of protons that an atom contains defines the element that atom will form. I think it makes sense. The number of protons a particular atom contains determines the element that atom will form. That was what they came up with. So this number was given a special name, and that name is atomic number. So what is atomic number? What is atomic number? Well, atomic number simply refers to the number of protons that are found in the nucleus of an atom. So if you pick an atom, the number of protons in there is the atomic number. So that means that if you look at this model of the atom you have on the screen, if you count carefully the red spheres in the nucleus with a positive sign on them, we have 4 of them in the nucleus. If you count carefully, we have 4 of them. 1, 2, 3, 4. So this atom has 4 protons. Therefore, its atomic number is 4. Simple. If you count and the number of protons are 8, it means the atomic number is 8. Why? Atomic number, the number of protons in the nucleus of an atom. So the atomic number ends up acting like the identity card of the atom, the ID. What does that mean? Basically, it means that once you know the atomic number of an element, you will know what, once you know the atomic number, you know what element we are discussing, no matter where that element is found. Look at this periodic table. Our focus is still on beryllium. If you look at the top right corner, we have a number there, and that number is atomic number. That atomic number means there are 4 protons in this beryllium atoms. So meaning no matter where you find beryllium, its atoms will have exactly 4 protons in their nucleus. No less than 4 and no more than 4. So that is an important discovery scientists made. So atomic number cleared and well understood, I hope so. But even more interestingly, when it comes to atomic number, which refers to the number of protons in the nucleus, more interestingly is when we are talking about neutral atoms. What does that mean? The number of protons is always equal to the number of electrons in neutral atoms. I take that again. When we talk about neutral atoms, when we say neutral atoms, we mean atoms that do not have charges. They are neither positive nor negative. They are neutral. In those instances, the number of protons are always equal to the number of electrons. Well, there is this popular questions that normally comes in BECE questions, where you'll be asked to explain why atoms can be neutral. Explain why atoms can be electrically neutral. So why atoms are electrically neutral? Let's explain it with this model we have on the screen. So for atoms to be electrically neutral, we have to pay attention to some vital points. All atoms have protons, and protons have positive charges. And then alongside these protons, in the shells or the orbits of the atoms, we have electrons. So the electrons are the green ones moving all around the nucleus. These protons or these electrons have negative charges. So protons are positive, electrons are negative, and they are all part of this atom. So in a neutral atom, these positive charges and negative charges are equal. That will make it neutral. So for example, if you look at the model we have on the screen, that stands for beryllium. This atom has 4 protons and 4 electrons. 4 protons, 4 electrons. If you check the protons, which are the red spheres with positive signs, we have 4 of them in the nucleus. And then if you check the electrons that are found on the shell, we have 4 of them, 4 greens, negative. So what that means is that the positive 4 protons will cancel out the negative 4 electrons. That means plus 4 minus 4 will give you 0, meaning the atom will end up being a neutral atom. So that is why the atom will end up having no overall charge, or will have a net charge of what? 0. So basically, I think this explanation makes sense why atoms are electrically neutral. Now, another mystery, why do some atoms weigh more? Scientists were successful in actually dealing with atomic number, explaining it, and getting to realize that the number of protons determine the element we are considering. But there was actually another puzzling issue they need to deal with. What was that? The fact is, some atoms of the same element, that means they have the same number of protons, ended up having different masses. If you pick chlorine, the considered chlorine atoms, they are all atoms of chlorine. But if they pick the first atom of chlorine, they pick another atom of chlorine, they realize that one is heavier than the other, although they all have the same number of protons. So that was quite confusing to them at the time. So they were wondering how that could be the case. But once again, the answer lies in numbers. What do we mean? The answer lies in the nucleus. You remember that alongside the neutrons of atoms, we have, or alongside the protons of the atom, we have the nucleus present. If you remember correctly, we have the nucleus, they have protons in there, and then we also have neutrons in the nucleus of the atom. So if you pick the nucleus of the atom, we don't have only protons. We have protons and neutrons. And these neutrons do not have any charge, but they have masses almost as equal as that of protons. We discussed that in our previous lesson. Good. These neutrons actually affect the masses of some of the atoms. So for example, what that means is that if you pick atoms of chlorine, although they are all atoms of chlorine, some of them have more neutrons than the other. I take that again. You can pick two different atoms, but they are all atoms of chlorine. They all have the same number of protons. But if you check the number of neutrons, some will end up having more neutrons than the other. But they have the same number of protons. So the neutron number, the number of neutrons, ends up affecting the total mass, or end up making one of the atoms heavier than the other. And in future lessons, we'll be discussing isotopes. This difference in neutron numbers leads to formation of what we call isotopes. So we'll be discussing that in future lessons. So in order to account for this observation that atoms of the same element end up having different masses, they came up with a different number, and that number was known as the mass number. And mass number was also called atomic mass. That is the mass of the atom. So what is mass number? Basically, mass number refers to the number of protons and neutrons in the nucleus of an atom. So if you pick the nucleus of this atom, in this nucleus you have protons and neutrons. If you add the protons and neutrons together, their total mass is the mass number, or atomic mass. So this nucleus has 4 protons, which are the reds, 4 protons, and how many neutrons? 5 neutrons here. The reds are 5 and the blues, the reds are 4 and the blues are 5. So the mass number will be 4 plus 5. That will give us 9. So the mass number of this atom is what? 9. So the mass number of this beryllium atom is 9. Basically, that's a simple explanation of what mass number is. So this number tells us how heavy the nucleus is. Mind you, when we are talking about mass number, which is also known as the atomic mass, it just refers to the mass of the entire atom. So ideally, it should be the mass of the proton plus the mass of the nucleus, neutron plus the mass of electron. But because the electron's mass is really negligible, it is not considered, it is ignored, and we focus on only the mass of the protons and then neutron. So as a result, the entire mass of the atom tends to be concentrated in its nucleus. So keep that in mind. So note this, nucleon refers to the total number of protons and neutrons in the nucleus of an atom. So that's one interesting point I want you to pay attention to. The atom has a central nucleus. Inside the nucleus, we have particles in there. The particles are protons and neutrons. Those particles are collectively known as nucleons. So that's one point to keep in mind. So what that means is that mass number is the same as nucleon number. So if you find mass number and another textbook says nucleon number, you're referring to the same thing. So mass number is the same as a nucleon number. The next thing we want to find is how to find the number of neutrons. So we've known that proton number, the number of protons, is the same as the atomic number. And mass number is proton plus neutron. Now, how do we find the neutron? As simple as this. If you know the atomic number and you know the mass number, you can find the number of neutrons using this formula. So number of neutrons is equal to mass number minus atomic number. Mass number minus atomic number. Why? Because the mass number means that you are adding the protons and neutrons. That gives you the mass number. And then the atomic number means the number of protons. So if you take the number of protons from the mass number, you end up getting the number of neutrons. We'll pick some questions and you'll get to understand that better. And lastly, let's look at the symbols for atom. How are atoms represented? So the symbol of an atom can be written to show its mass number at the top and atomic number at the bottom. What does that mean? Let's assume X to be a certain unknown atom. X is an unknown atom. If that is the symbol of the atom, then A will be the mass number. A is the mass number, and then Z is the atomic number. So take note of this. When it comes to mass number and atomic number, mass number is represented with alphabet A, capital letter A. Alphabet A, meaning atomic mass. Mass number is also known as atomic mass. That's why it is represented with alphabet A. Then atomic number is represented with alphabet number Z. It comes from a German word. So atomic number has a symbol of Z, and mass number has a symbol of A. And mass numbers are written at the top, and atomic numbers are written at the bottom. So for example, let's consider nitrogen. So nitrogen as an atom, the atoms of nitrogen have atomic number written at the bottom. Its atomic number is 7, meaning it has 7 protons. And at the top is its mass number. So this is how to represent atoms. Atomic number at the bottom, mass numbers at the top. Good. Let's pick some past questions. So an atom has an atomic number of 8 and a mass number of 16. State the number of each of the following in the atoms. I, the protons. I, electrons. I, the neutrons. Let's get started. If you look at this question, we've been given the atomic number. The atomic number is 8 and the mass number is 16. Atomic 8, mass 16. Now let's find the first number. So the number of protons is the same as the atomic number. We've already discussed that. So if you ask what is the number of protons is the same as atomic number. So therefore, the number of protons is 8. For the second part of the question, we have to find the number of electrons. Remember when we were talking about electrically neutral atoms? That in electrically neutral atoms, the number of protons is equal to the number of electrons. So in a neutral atom, the number of protons is equal to the number of electrons. That means the number of electrons in this atom is also 8, because the number of protons is 8. What about neutron? Remember also that in previous slides, we said to find the number of neutrons, you subtract the atomic number from the mass number. Subtract atomic number from mass number, that will give you the number of neutrons. So if you look at this, the number of neutrons is equal to N equal A minus Z. And we said A stands for the mass number. When we're looking at how atoms are represented, the symbols. A is mass number and Z is atomic number. So proton number will be mass number minus atomic number. So this means 16 minus 8. That gives us 8. So proton is 8, electron is 8, neutron is 8 in this particular atom. Next question. Explain why atoms are electrically neutral. This question came in 2004. Question 2BI. Why atoms are electrically neutral? And to put it simple, in a neutral atom, the number of protons, which are the positive charges, are equal to the number of electrons, which are the negative charges. So they cancel out. They are equal, so they cancel out. Our next set of questions will be multiple choice. First one, an atom has 9 or 20 nucleons and 9 protons. What is its neutron number? Remember we said nucleon or nucleon number is the same as mass number. Nucleon refers to the number of protons and neutrons in the nucleus. So this 20 nucleons is the same as saying that the atom has a mass number of 20. So how do we find the neutron number? So the number of nucleon is the same as the mass number, which is represents with A. Meanwhile, A, which is the mass number, is proton plus neutron, which means that the neutron will be the mass number A minus P, which is the number of protons. Using, we let the proton cross the equality sign chapter for the mass number. So A is 20 and P is 9. So the number of protons is 11. So this is how to solve this kind of questions. So the answer is 11. For the next question, an atom of an element is represented as X, 27 at the top, 13 at the down. How many neutrons are in the nucleus of the atom? What are the information we can glean from this particular question? The element is X. From this element, the atomic number of the element is 13. Because remember we said the atomic number are written or is written at the bottom. And the atomic number refers to the number of protons. So for this atom, the number of protons are 13. And the number at the top is the mass number. And the mass number of this atom is 27. And how do we find the number of neutrons? We subtract the atomic number from the mass number. That will give you the number of neutrons. So let's get right. So the atom will be given is X subscript 13 superscript 27. So this means that A, which is the mass number, is 27, and Z, which is the atomic number, is 13. And mass number is proton plus neutron. So meanwhile, atomic number is proton. So if you subtract the atomic number from the mass number, we will get the neutron number. So neutron is A minus Z, which is 27 minus 13, giving us 14. So the answer in this case is 14. If so far you don't really get the concept, you can go over this lesson. And during upload of this lesson, there will be timestamps, so you can go back and rewatch certain sections of the lesson again. Our next question is this. An atom of an element is represented as X12 subscript superscript 25. What are the respective number of neutrons and protons in the atom? Listen, what are the respective number of neutrons and protons? So first, what is the neutron in there and what is the proton? Automatically, from this question, we can see that the number of protons is 12. Why? Because the atomic number of this element is 12. So if the atomic number is 12, it means the number of protons is what? 12. So we have to now find the number of neutrons. Meanwhile, the number of neutrons will be the mass number, that's the number at the top, 25, minus proton number, 12. So 25 minus 12 gives us 13. So neutron number is 13 and number of proton is 12. So the answer will be 13 and 12. I hope that makes sense. If you have any question, you can leave it in the comment section and I'll do my best to explain it for you. Next question. An atom of an element is represented as X subscript 17 and 35. How many electrons are in the atom? How many electrons are in the atom? This is considered as an electrically neutral atom. So what is the atomic number of this element? The atomic number is 17, meaning the number of protons in this element are 17. And if it is electrically neutral, it means number of protons is equal to the number of electrons. So the answer for this question is 17. Good. So this has been a marathon. And thank you for learning with us. Thank you so much for learning with us. Subscribe to the channel so that you wouldn't miss our next lesson. For our next lesson, we'll be looking at electronic configuration. Electronic configuration. How The electrons in the atoms are arranged, and there are certain rules that they follow. So subscribe to the channel, share these videos with other students you know benefit from lessons like this. See you in our next lesson.